So we are recording this 16th problem, which is technically a match the column problem of JEE Advanced 2025. And the problem is an interesting one. It is technically just a formula based problem, but you need to be conceptually strong to answer this. The problem is asking list 1 shows various functional dependencies of energy E on the atomic number Z. Energies associated with these certain phenomena are given in the list 2. Choose the option that describes the correct match between the entries in list 1 to those in list 2. So over here the first one is E proportional to Z square. So over here I have attached a screenshot of H.C. Verma textbook, where it is stating that the total energy E is equal to mz square e to the power 4 upon 8 epsilon naught square h square n square, with a negative sign obviously. So this E is proportional to Z square. So over here E proportional to Z square is matching with the energy of radiation due to electronic transition from hydrogen like atoms. So over here we can say that P is matching with fifth option. So P in fifth option is over here B and C. So we can easily crop out the first option and the last option. Now we are talking about the next part, E proportional to Z minus 1. So E proportional to Z minus 1 is technically the formula of X-ray. So X-ray over here we use A Z minus 1 or Z minus 1 square. So over here we are saying that in the Moseley's law part we have an equation like this, where we write delta E is equal to RHC Z minus B square, and then the transition is taking place from n equal to 2 to n equal to 1. So we can write it as 1 by 1 square minus 1 by 2 square, or if it is from n1 to n2 we can write it as 1 by n2 square minus 1 by n1 square, or 1 by n1 square minus 1 by n2 square. So this formula matches with the energy of characteristics X-ray. So this one is for P and this one is for Q. So Q matches with 1. So Q is matching with the third option, so we can directly tick C over here, but I'm giving one more reference. E proportional to Z minus Z. So this formula is not in any of the text, but it is generally taught in classroom program. So it is the formula, or the semi-empirical mass formula, which is also referred as Weizsäcker formula, and it is stating that energy associated with the Coulomb interaction, that is Z minus 1 upon A to the power 1 by 3. So this term over here explains, why the nucleus with a large number of protons like uranium are less stable. It also partly explains why neutron-rich nucleus are more stable at higher value of Z. Extra neutrons help offset the proton-proton repulsion. So over here E Coulomb is the electrostatic repulsion energy, and over here we can say that this term R is matching with option 2. So 2 matches with R, or R matches with 2, we are still going with C. And then the last part, E is practically independent of Z. So we are looking at this part where E is independent of Z. So over here I am again attaching a screenshot from NCERT textbook, where it is stating the binding energy per nucleon is practically constant, practically independent of the atomic number for nucleus of the middle mass number ranging from 30 to 170. So it is matching with the fourth one, so S is matching with the fourth one. So if S is matching with the fourth one, then we can say we are strongly with C. So C is the correct option for question number 16 of this match the column type.